All right, in this video, we're going to be looking at inverse matrices to go with what we learned about determinants in the previous video. So some things to understand about inverse matrices first, note-wise. The n by n identity matrix is a matrix with ones on the main diagonal and zeros elsewhere. For example, the 2 by 2 identity matrix looks like this, with ones on the main diagonal and zeros elsewhere. 3 by 3 identity matrix looks like that, ones on the main diagonal and zeros elsewhere. You could do the same thing for 4 by 4, 5 by 5, etc. It's got to be some square matrix. As long as there's ones down the main diagonal and zeros everywhere else, that's the identity matrix for that size of a matrix. So if A is any n by n matrix and I is the identity matrix, A times I is equal to A, and I times A is equal to A. Think of it as if I were to take a number times 1, it doesn't change the value of the number. That's the identity property of multiplication. This is the identity matrix. Okay. Now, two n by n, two square matrices A and B are inverses of each other if their product in both orders is the identity matrix. That is, if I take A times B, I get I, and if I take B times A, I get I, the identity matrix. So this would be my product, or this would be my product. The square matrix A has an inverse if and only if the determinant is not equal to 0, and you'll see why as we find an inverse on the next slide. Symbol for the inverse is A with a little -1, so A and A inverse. Finding the inverse of a 2 by 2 matrix, a couple of steps to it. So find the inverse. I have 1 divided by the determinant of A times the matrix with some things rearranged. So what happens is the main diagonal gets flipped. It had been A and D, now it's D and A. The minor diagonal, well, that one stays put, but they become the opposite. Okay. Once I do that, I take this value, whatever it is, 1 over the determinant, and I distribute it to each term or each element in the matrix, and that'd be my inverse. As an example, here we go. The first thing you got to do is you've got to find the determinant to see if there even is an inverse. Well, 6 times 4 is 24, and 2 times 1 is 2. So 24 minus 2 is 22. Well, it has a determinant. That means it has an inverse. Okay. To find that inverse, we're going to take 1 over the determinant, 22, times a rearranged matrix. Main diagonal is going to be flipped. Instead of 6, 4, we're going to put 4 up here and 6 down here. Minor diagonal just becomes the opposite, -2 instead of +2, and -1 instead of +1. Sometimes you'll see an inverse left this way, where it'll be 1 over the determinant times the matrix, or you could take that determinant, 1 over the determinant, and distribute it. 4 over 22, which simplifies to 2/11ths, and -1 over 22, well, that's -1 over 22, and -2 over 22, it's going to be -1 over 11, and 6 over 22 is going to be simplified to 3 over 11. So there would be my inverse matrix. Okay. It's another matrix. It's got the same dimensions. It's just the inverse. You want to check it out and multiply this times that to see if it equals the identity matrix. Be my guest. We'll show you quickly how to do that on the calculator because, well, we'll wait just a second. So we'll skip these two examples. If I was going to find the inverse of a 3 by 3 matrix, that process to do by hand is very, very, very tricky. Pretty much impossible. You wouldn't want to bother with it. So instead, you're going to use your calculator. Okay. Now, you could use your calculator to find the inverse of a 2 by 2 or a 3 by 3 matrix. We'll show you how to do that. Now, previously, we have a 3 by 3 matrix that we edited as matrix A. I'm going to go ahead and show you how to find the inverse of that 3 by 3 matrix right now. We are going to go to the matrix menu, select matrix A, and we're going to find the inverse. Well, the inverse key is what we usually use to get to the matrix menu in the first place. So A inverse, there it is. I hit enter, and it spits out a matrix. Boy, that's ugly. Okay. Now, one thing, if these are ugly fractions or small fractions, maybe we can change them into fractions instead of decimals. Math, change to fraction. Well, let's enter to choose the first option. So it's going to take our previous answer, change it to a fraction, see if it'll do it. Hey, look at that. Kind of, again, goofy looking numbers, but there we go. Fractions, there's a 3 by 3 matrix. That would be the inverse. Now remember, if we take a matrix times its inverse, let's say we do that. Let's take A times the previous answer, which is this matrix. we should get the identity matrix. Cross your fingers, wait for it, wait for it, wait for it. Hey, look at that. 1's on the main diagonal, 0's elsewhere. So that's a pretty cool deal. If you would have done this in the other order, have the previous answer times matrix 8, we would have got the same thing because they're inverse matrices. Okay, so that's finding an inverse of a 3 by 3. If you want to do a 2 by 2, we'll just take a peek at it. So I'd edit a matrix first. I'll edit matrix B, and we'll make it a 2 by 2 matrix, and then we'll fill in the elements. I'm going to go back here and pick out. We'll do the same one that we just did. 6, 1, 2, 4 are our elements. 6, 1, 2, and 4. Quit to go to the main screen. Let's take matrix B and find the inverse. Enter. Get my face out of the way. Ooh, rough looking decimals, but remember, I can change them to fractions. Voila, 2 11ths, negative 1 over 22, negative 1 over 11, and 3 over 11. That looks the same as what we got right here. Awesome. So that's finding inverses on your calculator. Now, the other part of what you do is you're going to use inverses to solve matrix equations. Okay. So a linear equation like this one, 3 times x equals 12. Well, to solve for x, we use an inverse operation. Instead of multiplying by 3, I use the inverse, which would be to divide by 3. Now, another way to think about that is I would multiply by the inverse, which is 1/3. 1/3 times 3, well, that's 1. I end up with just x, right? If I do something to one side, I'll do the same to the other. I'll multiply that by 1/3 as well. 12 times 1/3 is 4. Oh, x equals 4 is my answer. Fantastic. Okay. Now, what we're going to do to solve this matrix equation, because notice instead of a lowercase x, it's capital X. It means the answer is a matrix. Okay. One matrix times another equals what you see here. Okay. Well, I can't divide by matrices. That doesn't work. So instead what I need to do is I need to multiply by the inverse, okay? So I'm going to label these things. I'm going to call this matrix A. So I have matrix A times matrix X is equal to matrix B, okay? To solve for X, I'm going to multiply by the inverse of A. Here I multiplied by the inverse of 3, 1/3, okay, multiply by the inverse of A. The inverse of A times itself, remember, is going to be the identity matrix, which won't change whatever matrix this is, so that's good. Okay, it's like this. 1/3 times 3 is 1. 1 times x is just x. Okay. If I do something on one side, though, I need to do the same thing to the other side. And here's a little trick. You need to actually put this inverse matrix in front. Order matters with matrix multiplication. Make sure you put this first. It's A inverse times B, not B times A inverse. Okay. Now, as I got this set up, I then will type these things into my calculator. So, clear what's going on here. I go to my matrix menu, edit some matrices, and I'll actually use A and B because that's what I talked about. So, 2 by 2, matrix A is going to be negative 4, 1, 0, 6. And now I'll go edit matrix B and make it whatever this other thing was, 8, 9, 24, 6. 8, 9, 24, and 6. Okay, I'm ready. I know that in order to get my answer, to get x, I'm going to take A inverse times B. Okay, and because I labeled them as such in my calculator, that's exactly what I'm going to do. I'm going to take A inverse times B. Hit enter. Here's my answer. There would be my matrix that would solve that matrix equation. Okay, negative 1, negative 2, 4, and 1. So, just and again, practicing it down here again, I think right underneath it, hey, what do I have? I've got A times X equals B. So I know that I need to then multiply by A inverse and put it first. Okay, A inverse times B. So make this A, make this B in your calculator. Again, if you want to use C and D or whatever it is, this is essentially all you got to do to type in to get matrix X. Okay, So that's solving a matrix equation, finding inverses of 2 by 2 and 3 by 3 matrices.